Today on the workbench is something very special. I have wanted one of these for my collection for so many years, and they just don't come up for sale very often. I won the eBay auction for this a couple days ago, drove down and picked it up today. This particular PET 2001-8 was made in 1977 and is in remarkably good condition. The keys are pretty clean and the plastic doesn't show any real signs of yellowing, and the CRT doesn't show any real signs of burn-in that I can see. The seller noted that when they tried to turn it on, it blew a fuse. So I've already been in here taking a look around. The latest date code on the chips on the board that I could find was the 36th week of 1977. So this was late 77, maybe September, or sold sometime after that. One problem that I've noticed already is that a lot of the screws on the bottom that hold things on, the nuts have come loose. This transformer isn't even held down. All the nuts that hold it on the bottom have fallen off. So I went to the hardware store today to pick up some fuses, and I got some nuts and lock washers to put on there to lock that down. Owner's manual says the fuse is a 1.6 amp slow blow. I have an assortment of fuses. This is a 1 amp, not a slow blow. And I'm going to try powering the system on with the board disconnected and the monitor disconnected. Just check the AC output. And just to make sure the monitor's not drawing any power from the transformer, I'm going to go ahead and disconnect it in here. We have 16.6 volts AC, and clearly the fuse has not blown. From ground to one of the AC wires, we're getting 8.3 volts, and another 8.3 volts on the other side, so the black wire must be a center tap. And with the monitor reconnected and drawing power, we're still getting 16 volts AC and a steady hum from the transformer, so the fuse definitely hasn't blown. I'm going to go ahead and check the rectifier diodes here. Getting a 0.5 volt drop across. Oh, sorry, that one's reversed. Yep, 0.4 volts. Here goes nothing. We have 9 volts DC there. And we have a picture on the screen. But it doesn't look good. I'm going to turn it off now. Characters on the screen are correct, so the character ROM is intact. There's noise on the picture, scan lines. It is a white phosphor screen, not green. And what we probably have is some bad RAM, maybe some other bad ROMs. I'm going to press some keys and see if anything on screen changes. Nothing. So I've popped in the Tynemouth RAM Rom Replacement Board. This is now replacing all of the RAM and all of the ROMs, so this should help isolate the problem. Here goes. Hey, there's a picture. Let's see if the keys work. A, B, C, keyboard works. Monitor is bouncing a bit. Let's pop this cassette in and try a load. O, A, D. Press play. The tape is running, hasn't found anything yet. Could be the heads need cleaning. Could be the belts need to be replaced. I still have the RAM and ROM replacement board in place, but I've gone ahead and put the original CPU back in here. That's the 1977 CPU that was in there. We'll test and see if the CPU is bad. CPU is fine, apparently. With that board configured to not replace the RAM, this is using the onboard RAM, but the ROMs are all still replaced. We're getting the same symptoms, so clearly the problem is RAM. Now finally I have the board configured to replace all of the RAM, but none of the ROMs. So we're going to be starting up here with all the onboard ROMs. Let's see what we get. So it looks like the ROMs are okay. And it appears to be basic 1.0. And unfortunately these RAM chips are not 2114s, these are 6550s, which are a lot harder to find. I did some troubleshooting off camera earlier. These chips here are the main system RAM, arranged from right to left. So this is the first 1 kilobyte. These two are 4 bits each, so the two together are 8 bits. First 1 kilobyte, 2, 3, 4, 5, 6, 7, 8. These chips back here are the video RAM, and they're the same RAM chips. So what I did was, one chip at a time, swapped it out into the video RAM to see if I get a good picture. If the picture looks okay, the video RAM is good, which means the chip is good. What I found was this chip was bad. These chips are 4 bits each, so you need both of them for 8 bits for a full byte. And these are the first kilobyte of RAM, 0 page. So if one of these chips is bad, the first kilobyte of RAM is bad, and the system won't start. So if we pull this out and move it down here to the last kilobyte of RAM, might as well leave this one out. Turn the system on now. What do we get? 6 kilobytes of RAM. The first kilobyte is used by the operating system, so there would normally be 7 kilobytes free. We've lost one, now we're down to 6. So, all original parts except for one missing, and the system is working. I'll try to locate some replacement RAM, but it won't be easy. These chips aren't made anymore, and they were rarely used when they were made. So these are MPS 6550 static RAM chips, and hopefully I can find some somewhere, but if not, the system still works on 6 kilobytes of RAM. So the only other thing wrong with it is the drive belt on the cassette drive. This belt is old, it's a little notched, it's stiff now, and was running very, very loose. I found a place that sells them, so I put a couple of belts on order. This one uses 2 belts. There's another one down here, and this one's in the pretty much the same condition. In the meantime, I'm going to do some cleaning. I don't know how well you can see it on camera, but there is a bit of grime all over this that needs to be washed off. There's also a lot of grime on the keys. Get in real close where you can see right there in the corners. So I'm going to take a cotton swab to the keys, wash down the case, get that grime off of it. The system is actually in surprisingly good shape. It looks pretty clean, but it could be cleaner. So, something to do while we're waiting for parts. I also want to do a more thorough check on the motherboard with the power supply in particular. So I'm going to check each one of the regulators one at a time here. See if I can verify the 5 volts. That one looks good. That's 5.015. Next regulator. 4.9. 4.9. See if I can see well enough to get in on this one. careful not to short it out. 5.0. All the regulators are within spec. So that's good. Since the cassette drive in this unit is not working, I was trying to plug in my external. This is my old C2N. Plug it in here, I get absolutely nothing. And I'm troubleshooting it, trying to figure out why. So I compare the connector on the unit here. Here you can see where the key is, and you can see the contacts in the connector. And you look at the plug here, plugs on like this. You look at the connector here and the key location, you can see that the contacts on this connector need to make contact with the top. Contacts on this connector make contact with the bottom of the board. Now, take a look. These pads don't actually contact anything. There's nothing there. Everything's on the bottom, which means this connector's definitely not compatible. And the external cassette connector over there is the same way. It's not going to work since the contacts are on the other side. So I'm going to start it up with the basic 2.0 ROMs. See what happens. That looks correct. The pound sign's there instead of asterisks. Let's see what happens. $0, 8. Looks like it works. Yay! The monitor's running hot now, so we need to be careful. There's 10,000 volts on the picture tube. And I have a selection of plastic adjustment tools. I see an adjustment right here. It turns out I think that is a vertical size adjustment. So things turned around so that I can see. I can increase the size or decrease it until it just touches the top, but then there's a lot of room on the bottom. Let's turn it off and back on and see what the basic prompt looks like now. That's better. Loaded a screen test program here. Let's see what this does. Notice the snow in here, these little bright pixels, is caused by the CPU writing to video RAM. That's normal on this model. Running a RAM test program now, and it appears to be testing 7K of RAM. 7, 8, 9, 10 cycles so far. If I tell it I have 8K, it fails right away at the 7K boundary. I'm going to let this run for a while. I want to do a thorough deep clean, so I went ahead and removed the monitor so that I could get underneath it. And there's a lot of gunk underneath there. Fortunately, the top case isn't welded or riveted like later models. So I'm going to take the top case off so I can give it a thorough wash. In the process of cleaning the keys, I got all in between the keys. Now I'm getting the surface of the keys. You can see this one here is clean, this one here is definitely not. Just a little bit of rubbing with a wet cotton swab. Fully disassembled, cleaned, and reassembled. Keyboard's clean, as is the rest of the system. Keyboard test. keyboard works perfectly. I ordered some replacement belts for this data set, and I was surprised that they came in already. I found these at a place called Console 5, one of the first places that pops up when you search for replacement belts for a 1530. They had a belt specifically for this model because this requires two belts. There's a drive belt and there's a reversing belt. I'm going to have to figure out how to get that belt out. Capstan comes off. Now, how to get the belt off of this. This piece right here is part of the entire frame, so it appears I'm going to have to remove the whole mechanism from the housing. Well, that wasn't easy, but I got it removed. I'm going to take some time to clean this out. We can get the belt off by bringing it around. There. This portion of the belt here goes around this. Once the capstan's back in there, I'm going to clean this. Then I have to solder this wire back on. So it is playing. Fast forward is not working. Rewind is working. Fast forward's not doing anything. I think I figured out the problem here is this gear right here is pretty well seized up. It's definitely not spinning freely. Push it with my finger, it does not want to move. As you can see, a significant disassembly was required in order to remove this piece. And this is really gummed up. Okay, so that gear is retained with a very small vinyl snap clip. Be careful removing that and don't lose it. I almost lost it. It flung across the room, but it hit the computer and landed back on the table. So I should be able to remove this now. Yep. So here's the problem. There's a bunch of old grease down in this recess. Rides up in here where there's a bunch of old dried, gummed up. Eek. Okay, now that that's cleaned up, let's see if I can't push this vinyl retainer back on there. Usually with these you just push hard enough with your thumb and they'll snap on. Close up there. Spins much easier now. Let's see what we get after that disassembly and reassembly there. That was quite a pain. So, play. Fast forward. Rewind. I've been messing with that tape drive for a couple of hours. I got it all back together finally. Let's see if it works. O, A, D. Press play. Fingers crossed. We'll find the program here in a second. There it is. This is a program I wrote for the 4032, so I don't even know if it'll work on here, but we'll see if we can list it and see if the tape drive works. Oh, the good old days, waiting for tape. Oh, and it loaded. Let's list it. See if it's all here. There's end. Let's see if it works on this one. It was written for the 4032. Oh, the two characters ended up in the same spot. No sound, but it works. Let's see how well the fast forward works. There's no locking mechanism on the fast forward, so you have to hold it down the whole time, and there's no counter on this tape drive. Rewind. Rewind works. Now let's see if we can save a program to tape. And then we can load one from this tape. And I have a brand new tape here that's blank. So, send it past the leader. Write complete. Rewind. Load one more time. Nope. Looks like we wrote something. Looks like it works. Well, the random number generator is not working because they're both starting out in the same location every time. A hit. Zeros at hyperspaces. That's supposed to be a random location, but it's not working. There's a difference in this version of BASIC, probably. With one bad RAM chip, the system's down to 6K free at startup. Should be 7K free at startup on an 8K machine. The first kilobytes used by the operating system. I ordered some replacement RAM chips. Fortunately, I was able to find some at a decent price. So, let's see if this fixes it. And go ahead and test all those RAM chips just to make sure they all work. This last one here is the bad one. These new chips actually are new. The date code on them says 1982. Yeah. So they're a bit newer than the ones in the machine. They don't quite look the same, but if they work, beggars can't be choosers. Very good. Let's see if we get 7K at startup. Hooray! Back to fully functional. Well, that's it. The system's back to fully functional. Full 7167 bytes free at startup. The monitor brightness is turned all the way down right now, and it should be able to go darker than this. So eventually I want to take the circuit board out of the monitor and check the capacitors and other components on there, but that'll wait for another video. And with that, I'll leave you on the requisite shot of playing Space Invaders. Thanks for watching.